welcome to the RPS project. In my continuing quest to understand transistors, I'm going to have another basic look at turning a transistor on. Sounds simple, but what I'm going to do is use a resistor capacitor sort of divider to turn on the base emitter junction, because obviously the base emitter junction has that 0.67 volts that it requires to turn it on, and obviously it's a current amplifier, so how much current is going to get onto that base. So I'm going to change the values of resistors and capacitors and see how that affects turning on the transistor. I'll do a quick diagram on the whiteboard so you can understand what on earth I'm going on about, and then we'll get onto the workbench and start having a look at it. So here it is on the whiteboard, basic circuit, very very simple. NPN transistor. Probably going to use something like a 2N222. Everybody knows that one. It's a very simple transistor. I'm going to put, actually that's wrong, because I'm going to put an LED in there. So let me just redraw that bit, because I'll need something to indicate when it comes on, which is going to be my badly drawn LED with a resistor in front of it to make sure it doesn't go bang. I'm going to put a 100 ohm resistor in there, so that's nice and simple, so we can see, well, I can see then when the transistor actually turns on. So the NPN, and then up here I'm going to have a resistor and then a capacitor, and basic electronics and principles means that as the capacitor charges, it'll reach a voltage where this junction will turn on. Because there's no resistor here, then the voltage that it will reach will be basically determined by this base emitter junction. But it also might be influenced by this resistor as well, because you know that resistor is going to restrict how much current flows, and that's going to be very much, I suppose, determine how this junction is going to operate and how much current can be allowed to flow through the transistor, because it is a current amplifier. So that's what I'm going to be doing. I'm going to be changing the capacitor value and the resistor value and see what happens. So let's get on with it. So here we are on the workbench with the little setup on this breadboard. I've got a couple of multimeters here, and this one is going to be reading the voltage at the base, and this is going to be reading the current at the base. I'm going to read the current after the resistor. No, I'm actually going to be reading the current flowing through the resistor capacitor part of the circuit. So I'll see what the total draw is onto that base across that circuit. So yeah, anyway, I'm going to be using several resistors. I'm going to be using a 100 ohm, 1k, 10k, 100k and a 1 meg ohm. And then capacitors, these little electrolytic jobs, I've got 1 microfarad, 47 microfarad, a, what is that, 100 microfarad, a 330 microfarad, and then this whopping big 1000 microfarad. Should be more than enough to show what the hell is happening on this circuit. So I'm going to start with shall I change the capacitor or the resistance? What I'm going to do is start with one resistor and change the capacitance. Oh, there's a bit of life left in there somewhere. Just discharge this capacitor, because I've got a capacitor on this, on the power supply side. Looks like things are about to touch. Keep everything apart from each other, don't want any short circuits. And I'm going to change the capacitor. So I'm going to start with this 1 microfarad capacitor, and I'm going to turn that on, and I expect the LED will come on instantaneously, because that little capacitor will charge up very very quickly. Oh, and change the current rating. Looking at it upside down, let's go to the highest setting. Well, look at that, I've got 0.96 volts and 39.5 milliamps. So yeah, it's a nice bit of draw, and it comes on instantaneously. Fantastic. So if I change the capacitor with that resistor, then what will happen? I presume over time what should happen is, well, I say over time because that's literally what's going to be happening. The time it takes for this capacitor to charge up is going to determine the amount of time it takes for this junction to turn on. So, and again, not really much difference, but then that capacitor is not really much greater than the one I've just taken out, because I've gone from a 1 microfarad to a 47 microfarad. Now we're going to jump up to this 100 microfarad. Just discharge a bit, because these capacitors are all holding lots of charge. Turn this on, and again we're still getting about the same. You know, that resistor is restricting the amount of current that can flow, so that's hardly going to change, which means the amount of voltage that it's going to allow onto the base is not going to change neither. But is it taking time to charge up? At the moment I'm not seeing that. I'm not seeing a charge time. It is slowly discharging, so there is a discharge time, but let's pull it out and go up to the 330 microfarad. Get that in there. Just take out the charge on that capacitor and turn it on and see if this has any, how quickly or slowly it turns on. And again, it's almost instantaneous, because this resistor is allowing through enough current quickly enough and voltage to charge up any capacitor quite quickly. And I expect it'll still be the same even with this whopping 1000 microfarad capacitor. So get that in there with this 100 ohm resistor, and discharge that one. Turn it on. Yeah, same again. So it doesn't matter which capacitor I have in there, that resistor is stopping or only allowing through enough, or as it were more than enough current to allow a decent voltage on the base to allow this circuit, the transistor, to turn on quickly, very quickly, almost immediately basically. I imagine if I was to put a scope on this, then I'd actually be able to start to see the time that it takes for this to turn on. So let's just go back to the beginning and change to the 1K resistor. So let's whip that one out. 100 ohm, because that's very small. It's going for the 1K. Get in there. I've got the 1K resistor in there. Lots of discharging going on, isn't there? Lots of find a way to create a circuit so it discharges itself, which they do in circuits. You know, you can get ones where it'll discharge itself through some high resistance or something else. But just testing to see how things work here, aren't we? So turn that on. Again, almost instantaneous. But you notice that the capacitance, the current that's flowing is a lot less. You know, we had nearly 40 milliamps before, now we've got 4, and the voltage is down slightly from 90 something, was it, 0.9 something, to now 0.81. So I bet if I was to change capacitance, let's just jump straight up to the 330. No messing about here. Let's see what happens with the 330. microfarad capacitor with that 1k resistor. Again, we've got this same scenario, that there's a lot less current and slightly less voltage, but yeah, it still comes on pretty instantly, doesn't it? I mean, it's not a problem, it works, it turns on, it's instant, or it appears almost instant. So let's just jump on quickly to the next one. I've put in this 1000 microfarad and turn that on, and again it's basically almost instantly. You know, there's this resistor is not doing much resistance, it's only a 1k, so it allows this capacitor to rise up very quickly to the 0.81 volts that it requires for this junction, for this transistor to turn on, with 4 milliamps flowing through this circuit, which is onto the base, which is great, fine, that all works fine. Now what if I was to change the resistance, but this time I'm going to jump right up to the 100k and get this 100k resistor thrown in there. I can get it in there, connect up this multimeter, there we go, and we will start again with the, like I say, the 1 microfarad. Let's throw the 47 microfarad in there for this time, and it's quite a small one. Discharge that one, get voltage right down, come on you bugger, taking a little while to discharge this one. Right, almost zero. So now we're going to turn this on. Now I'm expecting that this resistor will have much more of an effect, might even have a lot less current, so I'm going to move up the range on the current, or down the range. Is it? Yeah, down the range. And you should hopefully see that this voltage won't come on as quickly. It might take some time. See, that didn't come on instantaneously, did it? Actually, look how low that current is, and we've got just enough voltage to turn on the transistor, 0.7 volts. So let's turn that off, go this upper range. Look at that, we're on 2 millivolt range, so we've only got 42 microamps, sorry, on here, on the current, and 0.7 volts. So, and that did take its time to turn on. Of course, when you turn it off, there's still some charge in there. So imagine if I turn it on again now, it's like almost instant. But the first time I turned it on, it took a long time. So let's just take that out, put in the 330 microfarad. So that should take longer to charge up. You know, it's a bigger capacitor, it's going to take more time to charge. Let's get and discharge everything and turn it on. So I'm expecting it to take its time to come on, and look at that, the voltage is slowly rising and it slowly comes on. So yeah, so there's that that principle of, as the capacitor charges, as it reaches the 0.7 volts that's required for this to junction on the transistor to work, then it comes on. Brilliant. I suppose the really slow one, if I was to take that out, shove in this 1000 microfarad and a 1 megohm resistor, then this in theory should take a long time to turn on. Just connect that on there, just make sure I get everything discharged. So starting from the point of 0, and when I turn this on, we're going to get, wow, look at that, that is slow coming up. See, I've got 4 microamps, not milliamps, 4 microamps of current, and this is taking its time to charge up, and it is charging up though, because you can see the voltage rising, but it's going to take some time to charge. I'll let that just do its thing and charge up. And what I'm going to do now is, I'm actually going to, as it were, off camera, I'm going to go through these values and I'm going to do them individually. I'm going to start with the smallest resistor and then change the capacitors and see how it affects it and make notes on it, and then I'm going to go up and change to the 1k resistor and then go through the capacitors, and again I'm just going to go through them all one at a time and actually take down notes so I can actually see what's happening, and that way then when I come to do the math to sort out what I think is going to be happening, I can understand it and relate it to the notes I've taken from each resistor and capacitor combination. But this thing is taking its time to charge up, isn't it? That 1 mega ohm and this 1000 microfarad capacitor is definitely slow, but it does show that it is charging. There is charging there. I just need it to come up to about 0.65 and that LED hopefully would start to turn on. We're not there yet. It's going to take its good ass time about it, but I shall persevere and we shall see it turn on. Actually, I can see now that there's a tiny little glow from that blue LED. I'm not sure if you can as well, and it's slowly starting to turn on. It is turning on, as you can see. As that is very slowly rising, I'm getting more current, well, the same current but more voltage. It's allowing that current to be amplified in that circuit now as that capacitor holds its voltage charge. There you go, it's definitely on now. But of course we are, because of the way that this resistor is allowing this capacitor to charge up, as that junction turns on we'll reach a point where it can't charge up anymore because it's discharging as quickly as it's charging to hold the voltage, which is just about enough to make the junction turn on and make the transistor work. So there you go. Yeah, so now it's time to do the testing one at a time, take some notes, do the maths. I'm not going to do the maths this video because it's not what I want to do. I just want to have a quick look and see how this works, and now I'll sit down and do the hard work, which is to take all the notes and do the maths and prove that it's working as expected. So there you go, a very basic look at turning on a transistor just using a resistor and a capacitor. It's a very simple circuit. I just wanted to do it just to satisfy my own curiosity as to what was actually happening there, and it seems fairly simple. Basics of capacitor charging, resistor restricting the amount of current that can flow, which also restricts the charge time of that capacitor, and also its total voltage that it will get to before that base emitter junction turns on, and then the LED turns on. Of course, less current onto the base means less current through the transistor because it's a current amplifier. So that was very simple. Now I have sat down afterwards and done some of the maths, and I went through the different values and noted all that down and did a bit of maths work, and yeah, it just basically tells you that a capacitor will charge at a certain rate given the amount of current and voltage available, and that also determines then how that transistor turns on and how it's going to function. Nice and simple. I just wanted to do it just for the fun of it, just to see it, just to do it, which is always a good way of learning. And that's what I found with learning electronics, is that if you just take a very basic simple circuit, put it together, turn it on and change some values of stuff without doing all the complicated maths and stuff, just change some values and just see what happens, and make a note of it as you're doing it along, what you're changing and what you're getting as an output. Then you can then sit down afterwards and do the maths and understand what it is that it's doing. But it's nice to have a good play around and just see it happening. You know, hands on, always the best way. Anyway, if you like this video, give me a thumbs up. If you didn't, you know what to do. Subscribe, and all comments are welcome. See you next time.